So what we're looking for first is we're finding vertical asymptotes and the behavior around the asymptotes. So what I have here is in your booklets, it's in box number 9. Oh, hang on, let me just undo something because I made a big boo-boo. Now, if you have a look it's in box number 9 on page 9. I've actually just written this in my own words. Now, if we're trying to find vertical asymptotes, so vertical asymptotes is just your orange line here. So a line where there's no x value that exists. What we want to do is we want to solve the denominator for x. So if we're trying to find if we want to find a vertical asymptote, we're going to solve the denominator for x. So we're going to find where the denominator is equal to 0. So here, what we want to do is I'm just going to write here, f of x is equal to 0. So if we have y is equal to 1 over f of x is equal to 0. That's our equations for our asymptotes. And hopefully that makes sense, because if you remember from earlier, when we looked at fractions and also functions with fractions, when can the function not exist? The function won't exist when the denominator is equal to 0. So if we solve for where it's equal to 0, those are going to be our vertical asymptotes. So the solutions when we solve the denominator for x is going to be our vertical asymptotes. Okay, the second thing is to look at, on either side of this asymptote, what's going to happen is the y value is going to go towards infinity, positive infinity or negative infinity. So if you have a look up here, if you notice, we had a vertical asymptote on this y-axis. So this was our x is equal to 0. That's our asymptote, because when we solve for x here, we get x is equal to 0. And if you notice on either side, the graph goes towards infinity. So we've got on the left-hand side over here, we've got y goes to infinity. And on the left-hand side here, y goes to negative infinity. So what you'll notice is that on either side of our vertical asymptote, the y values will go towards either positive infinity or negative infinity. And how we can figure out which way it's going is to check the sign, checking the sign. I'm going to go through an example to show you that. So let's have a go at an example where we do this. So the first one here. So we have an example and there's a few parts. And this is example 12 in your booklets on page 10. So example 12, first part, we want to find the vertical asymptotes for y is equal to 2 over 3 minus x. So if you notice here, we've got a function at the bottom. This is a linear function. So here our f of x that we're dealing with is 3 minus x. This is a linear function that we have at the bottom of our asymptote, or bottom of our reciprocal, I mean. So if we're trying to find a vertical asymptote, what do? We solve for f of x is equal to 0. So if we're trying to find a vertical asymptote, we solve for where the denominator is equal to 0. So here, what I want to do for the first part is take that function that I have in the yellow box, 3 minus x, and I want to solve for that equal to 0. Because that's going to give me the vertical asymptote. So let's solve that. So we've got 3 minus x is equal to 0. So I'm going to move the 3 to the other side. So x is equal to minus 3, negative x is equal to minus 3. So our vertical asymptote is going to be at x is equal to 3. At x is equal to 3. So when we solve the denominator or solve the function at the bottom of our reciprocal, that is just going to give me the vertical asymptotes. So when we solve the denominator, it's going to give us the vertical asymptotes. Okay, part B, we want to check the sign either side and describe the behavior of the asymptote, around the asymptote. Okay, how we do this is we form a table of signs. This is just for this example here, but once we get more proficient at it, you'll hopefully notice there's a few patterns that make this a little bit easier. We're going to form a table of signs. And so here, I'm going to have x and y. I'm going to put my vertical asymptote value in the middle, and I know that because it's a vertical asymptote, there's no y value that exists for that point. So I'm going to put a big old x there. Okay, what I'm going to do is I'm going to pick values to the left here, and I'm going to pick values to the right here. So what's a value that's to the right or left of my vertical asymptote? Well, we could pick something like 2, 0, negative 100, whatever, and we're going to substitute it into my equation here, and all I'm worried about if it's positive or negative. So if I substitute 0 in, I would get 2 over 3, which is a positive number. So on the left-hand side, it's going to be positive. Now, if I substitute a number on the right-hand side, something like, for example, 4, I get 2 over negative 1, which is just negative 2, which is negative. So here, what this tells me is that from the left-hand side, so when I approach 3 from the left-hand side, or the negative side, which is what this side here is. So this part is me approaching 3 from the negative side, because if I'm going from the left-hand side, I'm starting from the negative and moving across. What happens? Well, it goes towards positive infinity. That's what we said over here. On either side, y is going to go towards infinity, either positive or negative. We don't know which one yet, but how we can check that is by looking at the sign. So here, because when x gets closer and closer to 3 from the negative side, y is going to go towards positive infinity. And the same way on the other side, so here, this side here is x going to 3 from the positive side, because we're going from the right down, we have y goes to negative infinity. So those are the two behaviors around the asymptote. We check the sign on either side, and it will tell me which way am I going to, which infinity am I going to? Is it positive or negative? Okay, so that's part B. Part C. Check large values of x to see if there's any horizontal asymptotes. Now, what this looks at is what happens when x becomes a very, very large positive number, and what happens when x becomes a very large negative number. So what we can do is we can just substitute a very large positive number into this into our function. So for example, let's sub in 100. What happens? We get 2 over 3 minus 100. So e.g., let's just do an example over here. So sub x is equal to 100. So we get y is equal to 2 over 3 minus 100, which is 2 over negative 97. Now, as that number gets bigger and bigger and bigger, it's going to become a negative number. It's going to be a negative number, sure. But what happens? When that denominator becomes bigger and bigger and bigger, what happens to the value of y? Well, y just gets closer and closer to 0. Y gets closer and closer to 0. So on here, y gets closer and closer to 0. Because when we substitute a larger and larger number in the denominator, we get a smaller and smaller number. If you remember, that was what we looked at when we looked at the hyperbola in advance. Now, in the same way, if I do a negative, when x becomes a larger and larger negative number, the same thing's going to happen. Y is going to go to 0 as well. So because of this, we have a horizontal asymptote. Y is equal to 0 is our horizontal asymptote. So here, therefore, y is equal to 0 is a horizontal asymptote. Okay, cool. The last step is that we want to sketch this function. So let's pull all of this together. And I'm going to do it over here. I'm going to draw my Cartesian plane. So this is part D. Now what I'm going to do first is I'm going to put on my asymptote. So if you notice, I had an asymptote at x equal to 3. So I'm going to put a dotted line at x equal to 3. I'll do it in red just so we can keep it separate. So this is x equal to 3. This is a vertical asymptote. And why I'm drawing this dotted line is just to show that my graph will get really close to this vertical line, but will never actually touch this vertical line at all. So it gets closer and closer to this vertical line, but doesn't actually touch. Now on the left-hand side, if you remember what I have written down in orange here, when x goes to 3 from the negative side, y goes to positive infinity. So what this tells me is that from the left-hand side, it's going to go, when I get closer and closer to this line, it's going to get closer and closer to positive, the y value is going to get bigger and bigger and bigger, and it's going to go towards positive infinity. And on the left-hand side, I've got the opposite. So instead of going to positive infinity, it's going to go to negative infinity. Okay, so those are the two behaviors there. And the other thing was when x goes to infinity and when x goes to negative infinity, y is going to go to 0. So this tells me that when x goes to infinity, y is going to go to 0 on this side. And when x goes to negative infinity, y goes to 0 on this side. So let's put this all together in one graph, and I'm going to put all of this in light blue so I can use all this information. So here I'm going to end up getting something that looks like this. Okay, that's my left-hand side. And on the right-hand side, I'm going to get something that looks like this. Now, at this point, you'd want to put in some points to show that this is in fact the given graph that you're looking at. So I'm going to put in the y-intercept. You can solve this yourself. I've got that this is 2 over 3. I'm just going to put in another random point over here. So for example, when x is equal to 4, y is equal to -2. And that just shows my equation here. So this question is an example of showing us how we can graph our reciprocal function by looking at first the vertical asymptotes. Now, what I'm going to do is I'm actually going to compare this with the graph of the function at the bottom of my reciprocal, so that 3 minus x. Now, if I'm going to draw over here, I'm going to draw on the same graph actually, just to make it a little bit easier. I'm going to draw 3 minus x in purple. Oh, I'll draw in light blue. Now, for 3 minus x, we get this type of graph. And 3, and so I'm going to draw a vertical line that goes down. So this is y is equal to 3 minus x in the light blue. Now, hopefully what you'll see in this graph is stuff that we expected. If you notice, when we go towards the left, so over here, when x becomes a larger and larger negative number, or a positive number, the value of y gets smaller and smaller and smaller and smaller. So that's what we notice there on that side. Now, a few more things to note. Similarly, on the other side, when x goes towards negative infinity, so that's what this part is telling me, when it becomes a larger and larger negative number, our graph also goes towards 0 as well. The graph of our reciprocal function goes towards 0. And when x goes towards 0, which is what we have down here, over here, y goes to infinity. And on the other side, when x goes towards 0, y goes towards negative infinity. Now, the other thing to note is if you have a look on the left-hand side of the red dotted line, our light blue graph, our y is equal to -3 minus x, it's positive. So everything on this side, I'll draw it on here, everything on this side, our light blue graph is positive, and our dark blue graph is also positive. It's above the x-axis. And in the same way, on the other side, and I'm going to draw this in orange, both our reciprocal graph and our original graph are negative. So another thing to notice is that when your original graph f of x is positive, then 1 over f of x is going to be positive. And in the same way, when f of x is negative, our reciprocal 1 over f of x is going to be negative. And that's what we have in the